This video is on parallel lines cut by a transversal, and we're going to go over a couple of the angle relationships that are created, and we're also going to talk about what I mean when I say parallel lines cut by a transversal. So let's get started. If you have the angle relationships packet, then we are on page 14, but if this video does not go with that packet, then just follow along. Yay. Okay. So two parallel lines never or do not, you can say do not or say never, intersect. So it means that they never cross. And if you see this symbol here, which is just two like L's, that means that the lines are parallel. So a line is named by an italics letter off to the side of the line. So this is line M, and this is line L, and this is line C. Yes. So that's the name of the line. And so I can call that line L. So if I want to say that line L is parallel to line M, I would write it like that. And I can put another, let's see if I want to make it cursive. I put another hump in there. Good. So that's how I would say it. So there's two lines that are going on forever and they're never intersecting. But then there comes another line. It comes along and it cuts through, intersects. So intersect meaning like crosses. So this line that crosses here, this is called line C. And if it intersects it, we're going to call it a transversal. This is called transversal, and that's how you spell it, which is the name up there. So now you can see that it's parallel lines cut, intersected by a transversal. So this right here is your transversal that's intersecting these two parallel lines. And there you go. So when a transversal, this is great writing here, intersects two parallel lines, angles are made. So you can see when the I'm just going to draw it over here. So if I had a line like here and then a line that was parallel to it like this, there are no angles in these lines. They're just straight forever. And there's this gap here in between them, and then there's stuff on the outside. But if I have another line that comes in straight and cuts these, then that's going to create 1, 2, 3, 4, 5, 6, 7, 8 angles. So 8 angles are created from that intersection. And then those angles have relationships and have certain properties that it's kind of cool the way it's made. So if I look at this, these angles, I can notice that the 4 angles that are made here are identical to the 4 angles that are made up here. They're like the exact same. And if I had more parallel lines that intersected this transversal, it would make more angles, and all of those angles that are made would be identical to the ones above it. Like you almost could slide them up and they would be the same shape and the same size. That means they'd be congruent. So we're going to talk about that relationship and we're going to talk about what that means for the angle measures. But let's start with something we already know. So before we get into all the ones that are congruent, let's talk about something we've already been talking about, which is supplementary. Supplementary angles add up to 180 degrees. And so when I have this straight line here, that's a straight angle. That straight line could also be a straight angle with this point here being the vertex. So that means these two angles here, angle 1 and angle 2, come together. These adjacent angles come together and make that straight angle. So that makes them supplementary. So two angles that form a linear pair add to a total of 180 degrees And they, oh, so you're right. That's not the right words there, is it? I think I have that in the answer key wrong. Now that I look at it, I think this should say straight angle. Oh, that makes more sense. Sometimes when there's blanks, you're like, what goes in that blank? That makes more sense. So two angles that form a straight angle and they add up to 180 degrees, they must be adjacent. So a linear pair, so let's take apart this word. Linear means line. So the word linear, pause this for a second and say the word linear like 3 times. Okay. So linear starts with the word line. So it means it's a line. And then pair means two. So it's two angles that make a line. Two angles that make a line. It's a linear pair. That means they add up to 180 degrees. So angle 1, and angle 2 are a linear pair. And there's more sets than that. I can go all around actually. I could look down here. See, there's also a line this way. This transversal makes a straight angle also. And so angle 6 and angle 7, if you kind of look at that, see, they make that straight angle too. So 6 and 7 are also linear pair. So what are two that are not a linear pair? Well, if I look at angle, there's lots of non-examples too, but here's one for you. Angle 4 here and angle 5. Now, I'm going to spoiler alert. Angle 4 and angle 5 do add up to 180 degrees. You'll see that later as we do problems, but they're not a linear pair. So even though, so I'm going to write that down. So angle 4 and angle 5 are not a linear pair because even though they add up to 180 degrees, they're not on the same line. They're not adjacent. They don't share a common vertex. So that's why they're not a linear pair. So a linear pair has to be on the same line. Okay, that's tricky, but they are going to add up to 180 degrees. Yay.